Lesson 6.2, Greatest Common Factor, also GCF. Now, in our previous section of Algebra 1, we multiplied and raised polynomials to powers. We used FOIL, table method, and the reverse of this, the reverse of multiplying polynomials together or monomials together or raising them to powers is to factor them. So, for example, in the past, we had 2x plus 3 times x minus 2, and we would FOIL that out. So first, outside, inside, last. And that would give us 2x squared minus x minus 6. So that would mean that 2x squared minus x minus 6 would also equal 2x plus 3 times x minus 2. This is the factored form. And the first step to learning how to factor polynomials is we first need to factor out the greatest common factor of all the terms. That's always the first step, is to look for a greatest common factor. So we'll start actually with monomials, but then we'll factor binomials, then trinomials, and finally general polynomials. And let's first review greatest common factor. Okay, we'll find the GCF of the following pairs of numbers. The greatest common factor is the largest number that will divide evenly into two or more numbers. Okay, so it's the largest number they have in common, hence the common factor. So we look at 12 and 18, 24 and 48, or 27 and 36. And we'll find the greatest common factors of these pairs of numbers to start. So let's start with 12 and 18. We can use a list of factors, or we can use a factor tree. Using a list of factors, we write down the two numbers, and we start listing the numbers that will divide evenly into them. 1 obviously divides into everything. 2 goes into 12, 3 goes into 12, 4 goes into 12, 6 goes into 12, and 12 goes into 12. With 18, we have a 1, 2 goes into 18, 3 goes into 18, 4 does not, 5 does not, 6 goes into 18, 9 goes into 18, and 18 goes into 18. Once we've listed all of the possible factors, we move along until we find the largest factor that they have in common. So the GCF is going to be 6. Now, this works out okay for small numbers like this, but if you have large numbers like 396, that's a lot of factors, or a lot of possible factors, and it might not be so easy to list all the factors, and that's when factor trees come in handy. So what we do is we list the two numbers, and then we create the factor trees. 12 is 2 times 6, 6 is 2 times 3, 18 is 2 times 9, and 9 is 3 times 3. Once we have the factor trees made, we circle the numbers that they have in common. These are common factors. So they have a 2 in common and they have a 3 in common. The GCF will equal those common factors multiplied together. Now, because they have a 2 in common, we list the 2 once. They have a 3 in common, so we list the 3 once. So the GCF would be 6. Okay, looking at our next example, 24 and 48, we'll list our factors. 1, 2, 3, 4, 6, 8, 12, and 24. And if you look, there's kind of an interesting pattern. 4 times 6 is 24, 3 times 8, 2 times 12, and 1 times 24. For 48, I have a 1, 2, 3 goes into 48 because 4 plus 8 is 12, and 12 divides by 3, so 48 will divide by 3. 4 goes into 48. 5 does not, 6 does, 7 does not, but 8 does. Now 6 and 8 multiply to make 48, so 4 times 12, 3 times 16, 2 times 24, and 1 times 48. I find the largest number that they have in common, which is 24, and that is my GCF. Using factor trees, I write down 24 and 48, and I factor them. So 24 is 2 times 12, 12 is 2 times 6, and 6 is 2 times 3. Now, one thing, when this 12 becomes 2 times 6, it's gone. These are gone now, because the 24 is 2 and 12, the 12 is 2 and 6, and the 6 is 2 and 3. 48 gives me 2 times 24, so 24 is 2 times 12, 12 is 2 times 6, and 6 is 2 times 3. They have a 2 in common. They have another 2 in common. They have another 2 in common. And finally, they have a 3 in common. So my greatest common factor is going to be 1, 2, 3 2's, 1, 2, 3, and a 3, and when I multiply those together, I have 4 times 6, which is 24. And finally, our last pair was 27 and 36. Listing my factors, I have 1, 3, 9, and 27. For 36, I have 1, 2, 3, 4, 6, 9, 18, 12, 18, and 36. The largest factor that they have in common is a 9, so my GCF will equal 9. Using factor trees, we'll factor each of these numbers. 27 is 3 times 9. 9 is 3 times 3. 36 is 3 times 12. 12 is 3 times 4. And 4 is 2 times 2. They have a 3 in common. They have another 3 in common. So that's 2 3's. So my GCF is 3 times 3, which is 9. So as you can see, there's 2 methods to find the GCF. Okay, finding the GCF of 2 monomials. These include variables. So what we do is we find the GCF of the number, the coefficients, which is the number part. And then I take the variables in common with the smallest exponent. Okay, so here, for example, I have x squared and x. They have an x in common, and the smallest exponent will be that 1. So what I'm going to do is I'm going to go ahead and use factor trees for this. So 25 is 5 times 5, and 15 is 3 times 5. So they have a 5 in common. So I'll write down that 5. Now I have 2 x's and 1 x. So 1 x. I have 1 y and 4 y's. So 1 y. I have 5 z's and 3 z's. So I can bring out 3 z's. That's the greatest common factor of those 2 monomials. Here I have a 26 and a 39. 26 is 2 times 13, and 39 is 3 times 13. So they have this 13 in common. I have 3 A's and no A's, so I can take no A's. I have 1 B and 5 B's, so I can bring 1 B. And I have no C's and 1 C, so I can bring no C's. So my greatest common factor would be 13B. Okay, factoring out of a binomial, we do the same as if we're factoring out of the two monomials. I'm going to look at the 6 and the 21 and find the greatest common factor in each of those. Okay, and in this case it's going to be a 3. I have 2 x's and 5 x's, so I can bring out 2 x's. 7 y's and 3 y's, so I can bring out 3 y's. 11 z's and 1 z, so I can bring out 1 z. Now, that was my first step. I find the GCF. Then my second step is to put in parentheses what's left. Okay, so here's my GCF, but I'm factoring that out of this binomial. So if I have this 6 and I divided it by 3, I'm left with 2. There were 2 x's, I took 2 away, so there are none left. There were 7 y's, I took 3 away, so there are 4 left. There were 11 z's, I took 1 away, so there are 10 left. I keep the sign the same. 21 divided by 3 is 7. There were 5 x's, I took 2 away, so there are 3 left. There were 3 y's, I took 3 away, so there are none left. There was 1 z, and I took 1 away, so there are none left. And this is the factored form of that first binomial. Now I'm going to do the 42 and the 7. I have 7 times 6, and 6 is 2 times 3. Here I have 7 times 10, and 10 is 2 times 5. So they have a 7 in common and a 2 in common. And 7 and 2 is 14. 2 p's and 2 p's. 4 q's and 5 q's, so I can bring 4. 3 r's and 5 r's, so I can bring 3. If I take 14 away from the 42, I'm left with 3. There were 2 p's, I took 2 p's away, so there are no p's left. There were 4 q's, I took 4 away, there are none left. 3 r's, I took 3, there are none left. Same sign, so minus. I've taken these out, so I'm left with a 5. 2 p's, none left. 5 q's, so there is 1 q left. And 5 r's, I took 3, so there are 2 left. And this is the factored form of that binomial. Okay, in order to factor in a trinomial or a general polynomial, I'm going to go ahead and number these because I don't think I'm going to have enough space to write it all out. 22 is 2 times 11. 12 is 2 times 6, which is 2 times 3. 16 is 2 times 8, which is 2 times 4, which is 2 times 2. Now, I have 3 terms, so they have to have a number in common to all 3. So I have a 2, and a 2. So I have to link this 3 times. Now this is the only number all 3 have in common, so that's the only number I can pull out. So I bring out my 2. I have 1 x, 2 x's, and 1 x, so I can bring 1 x out because they all 3 have an x in common. I have 1 y, and 2 y's, so I can bring 1 y out because they all have a y in common. Now when I take this 2 away from the 22, I'm left with 11, but I took both the x and the y, so there's none of those left. I keep my sign the same. 12, I take away the 2, and I'm left with 6. I had 2 x's, I took 1, so there's 1 left, and I took the y, so there are none of those left. Same sign. If I take the 2 away from the 16, I'm left with an 8. I took the x, so that's gone. There were 2 y's, I took 1, so there's 1 left. So just keep in mind, if you're using more than a binomial, it's the greatest common factor of all 3 terms. So let's look at this polynomial, which has 4 terms. I'm going to factor the 36 and the 9 and the 18 and the 54. Now it doesn't matter how you split these, as long as all your division's correct, you'll get the same numbers at the end. Okay, now I can only pick numbers that they all have in common. These 3 have a 2, but this one doesn't, so I can't use a 2. This has a 3, that has a 3, that has a 3, and that has a 3. So I can use one of the 3's. Okay, and then I have another 3 here, another 3 here, another 3 here, and another 3 here. So I actually had 2 3's in common to all 4 terms. So my GCF is going to be 9. So I'll have a 9 that I can pull out. I have 2 A's, 3 A's, no A's, and no A's. So I cannot pull out any A's. I have B's, no B's, B's, and B's, but this one has no B's, so I can pull out no B's. I have a C, C, no C's, D, no D's, D, D, D. So in this case, I have nothing in common with the rest of these. So my only GCF is 9. So everything else gets left behind. So 36 divided by 9 is 4. 9 divided by 9 is 1. 18 divided by 9 is 2. And 54 divided by 9 is 6. And since they had no letters in common to all 3 or 4 terms, we could not factor out any letters. So be very careful of that. Now this could be factored by grouping, but we're going to be doing that a little bit later. So keep in mind that term, factor by grouping, because that will come up at a later date.